Welcome to our Azure Incident Retrospective. I'm David Steele.
I'm Sami Kuba. We work in the Azure Communications team.
In addition to providing a written post-incident review after major outages, we also now host these retrospective conversations.
You're about to watch a recording of a live stream where we invited impacted customers through Azure Service Health to join our panel of experts in a live Q&A.
We had a conversation about reliability as a shared responsibility. So this includes our learnings at Microsoft, as well as guidance for customers and partners to be more resilient.
We hope you enjoy the conversation that follows. Super, and today's incident we're going to focus on is an Azure OpenAI service interruption. This is where customers would have experienced 500 errors when trying to use Azure OpenAI. It affected multiple regions. It impacted customers from the 16th to the 17th of July, but the impact was 2.5 hours overall together.
That's right. So to talk us through the incident and our learnings today, I'd like to introduce the engineering leaders joining us as our guests. First up in person, we have Shelley Gore, our Partner Engineering Director. And joining us virtually, we have Chip Locke, our Principal Architect. Both Shelley and Chip are from the Azure AI Platform Engineering team, and they're here to talk us through what happened today.
Super. Chip, if I could start with you, before we get into the actual incident itself, you mentioned that you're part of the platform team for Azure OpenAI. Could you speak to us a little bit about some of the dependencies that Azure OpenAI has so that everyone here can understand the relevant services, components, and the ingredients that we're discussing here today?
Certainly. So Azure OpenAI runs on Kubernetes, on the Azure Kubernetes service, and the relevant components we're going to talk about are front-end serving components, and I will be talking a bit about the Istio service mesh. That is a public open source service mesh based on the Envoy platform for HTTP traffic handling.
So, and on a normal day, how do these things orchestrate together?
So we run on top of Azure Kubernetes service, we run the Istio service mesh, and then we use that mesh for folks who are not familiar. It is a way to control how services speak to others. So it handles service discovery. Service A wants to talk to service B. And then on top of that mesh platform, we run a variety of containerized applications that handle traffic serving.
Got it. So those are the pieces of our story here. Look, but before we get to what went wrong on this fateful day, Shelley, I'd love to bring you in here to help us understand the customer impact. We want to start from that perspective. What did this feel like for customers? We've mentioned that there were, service interruptions. What would that actually feel like?
Yeah, like Chip said, this platform is the hosting platform for Azure OpenAI Inference. And from customer point of view, basically, all of your inference calls, including chat completions, assistance calls, and some other orchestration calls to the model endpoint would be impacted.
Got it. So those were getting 500 errors, those were getting timeouts, it just wasn't working, computer says no. I'm interested in the regional element here, because in the post-incident review, we mentioned Sweden Central as a region specifically, but I understand the impact was actually broader than that.
Correct, because a large portion of our customers opting for this offering called a global offer.
Well, now, global offering, I'd love to slow this down a little bit to understand it, because whenever I think of Azure, I think of a virtual machine, and I pick what region it goes in or what zone it goes in. But if I'm using the global offer for Azure OpenAI, it doesn't work the same.
Correct, and that's very specific to the AI workload because of the reason that GPU scarcity is one of the biggest problems we are trying to solve. That in conjunction with model availability makes certain models only available in certain regions. Now, in order to facilitate customers from around the world to be able to leverage those model functionality as well as the GPU capacity, we have this global offering where your Azure resource can be in a certain region, but your inference call is actually routed to wherever we have the capacity and the model that matches your request.
Got it. So in that case, we're saying, Microsoft, you decide where this will run, and even if the customer didn't actually pick Sweden, that we might have chosen to put their workload in Sweden temporarily.
Yes, correct. Yeah, and that routing decision is mainly dependent on traffic load on that particular model endpoint.
Great.
Super. That's interesting. So we know that customers, they'll make a request and it'll be distributed. So if we go back to the actual event itself, and if we go on to that day, Chip, maybe we can refer back to you again. Could you help us understand the trigger event or the conditions that set things up here? In the PIR, we mentioned that there was part of a release, part of a deployment, and we mentioned Sweden Central, as David and Shelley alluded to. Was Sweden Central first up in our deployment? Is that why they were affected differently than some of the other regions?
No, actually, Sweden Central is one of our busier regions, and you'll see that obviously from sort of the broad impact, the multi-region impact that we had here. It is actually last in our set of regions, so we deploy using, internally it is known as safe deployment practices, and we are very careful and deliberate about how we deploy. The reason that, and so this was the last in a 5-ring chain of deployments, went with several other regions which were not impacted. So the reason that this happened in this region basically comes down to, as we were building out these Kubernetes clusters and this hosting platform, we had made some changes specifically in Sweden Central that caused, we have 2 Istio gateways, and the root cause effectively was that we configured a host name to serve traffic in both of those Istio gateways. Istio internally, when it sees a conflict with host names, will pick one gateway as the winner. In Sweden Central, the age of the Kubernetes object was reversed from what it is in all of our other regions. And so Istio picked a gateway that was not capable of serving most of the traffic. And so what was being deployed was a configuration update to support these host names on these 2 gateways, as we were unfortunately not aware that this was the behavior in Istio. The gateway that had been disabled in previous deployments was not critical to live traffic flow. And unfortunately, this was the gateway that ended up trying to, that was picked by Istio. The other gateway was disabled, and so we were unable to serve traffic normally.
That's great to understand. I just want to repeat something back to you because I think I heard it. It sounded like this release that caused problems in Sweden Central had already landed successfully in a bunch of other regions and hadn't caused those problems. Is that how it was able to slip by undetected, Chip?
That is correct.
Got it. The other thing, I'll borrow a line from David and say we don't say root cause. We know that complex systems fail in complex ways, and so we'll put $1 in the jar on your behalf, Chip.
Very good. I mean, Chip, I'd love for you to talk us through the incident. I don't know how directly you were involved here, but I'd love to understand how we detected that there were issues going on, kind of how we investigated those, and eventually how we were able to mitigate, given the problems you described.
Certainly. So I was actually on the call when this occurred. So detection, I'll start there. Detection occurred through automated monitoring. We have continuous monitoring for all of our regions that ensures that we are able to serve traffic. If we see any anomalous behavior in that traffic serving, an alert fires, our engineers are brought in. I was not the on-call engineer at the time, but I was paged in. For this, I hopped into the call, sort of began debugging and looking into what was going on with the traffic serving in this region. And then I actually found eventually the issue and was able to mitigate it live and get the traffic flowing again.
Super. And Chip, if I can stay with you again, I'm sorry to keep pestering you, but as we pivot towards learnings, particularly for our PIR, in the PIR, we listed a few. One of the ones that caught my eye was around safe deployment. Now, you mentioned here Sweden Central was last on the list to get the update. Did we deploy the correct way? Like, how did we deploy versus how should we have deployed in order to catch something like this?
It's a fantastic question, and you're not pestering me at all. So what we've learned from this, and what we had learned actually from some other incidents, is that there's a few things we've learned. So while we do, yes, use safe deployment practices, there's more that we can do. There's more that we can do to be better here. One of the things that we can do to be better is to slow down these deployments to some of these more critical traffic serving components, right? So versus maybe an application deployment, that's one microservice in a sea of some and 20, 30, more than that. These things that serve traffic that are directly responsible, we want to slow those down. We also want to reduce the blast radius. So when we do safe deployments, even within a region, we want to slow that down and also add more individual units that we can deploy to reduce that impact. And then beyond that, there's a good bit of monitoring that we want to improve on as well.
It's a great segue. So the second repair item that we touched on was monitoring and alerting. So sometimes for these big incidents, we see, just big monitoring gaps. Hey, we didn't know about this until a customer reported it to us. Something slipped by. But in this case, our monitoring did catch it. So what are the learnings here? We want to catch it better or faster, or what does that look like?
So, great question. So I think where we looked at this, the monitoring did pretty good. We feel that we can improve the speed of the detection. Without getting into specifics, I think we can, we believe actually that we can make that detection faster. And then beyond that, we can add some additional over-the-top monitoring. So as I mentioned earlier, we had these two gateways that were misconfigured. There was a lack of monitoring on that second gateway that we would introduce. We can also add, and will add, monitoring to prevent this misconfiguration that I'll actually be rolling out here in our platform in the next 2 weeks. So we will have monitoring that catches this misconfiguration ahead of time. We're going to follow up with the Istio folks, with the Istio open source community as well, and sort of discuss this behavior because it was very surprising to us that this happened. It makes sense. What Istio does sort of makes sense at a high level, but I think this is surprising behavior. And if you look at their GitHub issues, you'll see 1 or 2 people that were kind of caught by this unaware. So there's maybe some improvement we can not only make in our own platform, but also just bring to the Istio community as a whole. And then beyond that, like I said, improve the speed of monitoring, improve the depth and the breadth. So yeah, that's it, actually.
Super. Shelley, I don't know if it's possible if I could just pivot over to you for a while. When we talk about, we know that outages are inevitable, but we also know that impact doesn't necessarily have to be, depending on how customers are architected. We generally will tell customers, hey, you should use the distributed model. Would that have helped customers be resilient to this type of outage or this outage in this case? Was there anything customers could have done to be immune to impact?
I think immune is going to be a very difficult goal to achieve. Reducing the impact is possible. Now, AI workloads, the demand for AI workloads is outpacing the global capacity footprint that we can keep up with. So, in order for a customer to balance between I want to get access to the newest models, I want to get access to the latest and best, versus I want my production application to be fully resilient on a regional outage, is a balance that our customers do face and have to make some decisions. That's why we do offer 3 different tiers in our resilience portfolio. We have global offer where your traffic can be routed anywhere. We have data zone offer where your traffic is bound to a specific data residency zone. And we have regional offers. The choice is that the global offer gives you the fastest access to any of the newest models versus, on the other hand, regional has more limitations on availability. So depending on your application scenario, you can make those choices based on what your needs are.
I'd love to understand that, because I know in the post-incident review, and often with Azure OpenAI incidents, we tell customers, hey, as a general recommendation, you should have endpoints in multiple regions. How should we think about that relative to those 3 resilience options you mentioned? Can I use endpoints in multiple regions while also using the global offering, or do I have to pick specific regions if I choose to have endpoints in multiple regions? How should I think about that?
Right. If you have an endpoint in different regions that use global offering, then there's a chance that they all point to the same backend model instance, which would mean that if that particular model instance have an issue, you have multi-region impact. So if you have an endpoint that are specifically regional, then you don't have that particular impact. Right. But like I said, it's a choice. It depends on what your needs are, what's the most important to you. Now, as a service itself, we continue to improve our global routing intelligence to make sure that if there is a backend model endpoint is having issues, we can quickly reroute. Those are continuous improvements that we are adding to the service.
So for increased resiliency, the global option seems to be the better one. And if you have to be bound to a zone or a region, there's less inherited resiliency. Is that a rubric to kind of summarize it?
Right. The global offer allow you to offload that resiliency problem to the service to deal with it, but the regional gives you more control.
Thank you very much. That's very helpful.
Cool. That's great to see. I've saved my last question for my co-host Sammy here. Sammy runs our incident communications team. So now that we've heard back from our relevant platform teams about their learnings and repairs, we'll ask Sammy, how did we do from a communications perspective? Do we have any learnings or repairs to help keep customers up to date?
So from a comms perspective, as Chip mentioned, we detected this pretty quickly. And some of these service level indicators that we have are used to trigger automated comms. So in this case, Brain, which is our system to communicate to impacted subscription, fired within about 20 minutes. And as Chip said, that there's always room to shave that off a little bit. Ideally, we'd like to be under 15, but it fired pretty quickly. For the customers that were impacted, we told them which resources were impacted. So they're getting 500 errors, and we were able to highlight the instances within Azure Service Health. One of the challenges that we had in communications is that the automation was taking over. As humans got involved, we didn't augment that information with what happened. So we were fast to tell customers around what's happening. It took us a while to communicate to all the impacted customers, like that automation was coming in and being batched and processed. But we missed an opportunity to tell our customers what was happening during. And it's great that we have these discussions and our PIRs are transparent, but we're really trying to shift left and say, let's tell customers during the incident and not always wait for the dust to settle. So we still have work on flexing that muscle during an outage to tell our customers what's going on. Not that it changes the outcome, but it allows customers to come into the war room with us, to come into the calls with us, and to understand where we are in terms of identifying causes, mitigating, and even giving ETAs. If we can, and sometimes we get it wrong, which is fine, but we want to give customers a general yardstick of when we think we're going to be mitigated.
That's helpful to understand. I mean, that transparency is so important. It was a few years ago that, the updates that we would provide would say, we are applying mitigation, without actually explaining what mitigation we were applying. So we were quick, but maybe we could have been more detailed in those comms.
I think so.
Thank you for watching this Azure Incident Retrospective.
At the scale of which our cloud operates at, incidents are inevitable.
Just as Microsoft is always learning and improving, we hope our customers and partners can learn from these too, and provide a lot of reliability guidance through the Azure well-architected framework.
To ensure that you get posted incident reviews after an outage and invites to join these live stream Q&A sessions, please ensure that you have Azure Service Health Alerts set up.
We really focused on being as transparent as possible and showing up and being accountable after these major incidents.
Whether it's an outage, a security, or a privacy event, Microsoft is investing heavily in these events to ensure that we earn, maintain, and at times rebuild your trust. Thanks for joining us.